Okay, so in this video, what we're going to do is summarize all the rules we know for writing formulas and for naming compounds. So we're going to start with writing formulas, go through some of the ways to identify what you're going to do, and then we'll do chemical compounds. So apologies for the way this looks. I worked my best on the animations. First thing you want to do when it comes to writing formulas, that means writing the symbols and writing the subscripts. You want to identify how the name ends. If it ends in the word acid, the next thing you want to do is hydro in the name. So if it was hydrochloric, you do something different than if it's chloric. Both of them are acids. So if it says hydro, that means you're going to drop and swap H with a 1 plus with an anion on the front of the periodic table. H1 plus, when it's written first, identifies something as an acid. So that's how you know. So for example, if I gave you hydrosulfuric acid, you would take H1 plus, you would look on the front of the periodic table for sulfur, which is -2, drop and swap, and you get H2S. If it doesn't have the word hydro, something like chloric acid, you're still going to drop and swap H1 plus because that's what acid means. But this time you're going to use something on the back of the periodic table. So if your acid ends in the word ic acid, you want to find the polyatomic ion that ends in ATE. If it ends in OUS acid, then you want to find the polyatomic ion that ends in ITE. So if I had nitrous acid, doesn't have a hydro, I'm going to drop and swap H1 plus with NO2 1 minus, and I get HNO2. If I had nitric acid, I'm going to take H1 plus, and this time I'm going to drop and swap with nitrate, NO3 1 minus. So very similar formulas, very different names. Okay, so that's how you do acids. If it ends in IDE, you want to identify whether there are prefixes in the name or not. So if there are prefixes in the name, you want to write down the symbols. Use the prefixes as subscripts. You do not drop and swap. You do not use charges, and you do not reduce. So for example, if I had dinitrogen tetroxide, so if I had something like dinitrogen tetroxide, di means 2, so N2. Tetra means 4, O4. That's it. I don't look at charges. I don't look at reducing. I didn't swap the numbers. All I did was literally write them down. Okay? If it doesn't have prefixes in the name, you want to write down the symbols and the charges. You drop and swap, and you reduce if possible. So if I had magnesium oxide, I look up Mg. It has a +2 charge. I look up O2 minus. It has a -2 charge. I drop and swap. When you do that, you get Mg2O2, but that reduces to 1:1. These you reduce. If I didn't, if I still have something that ends in IDE, I look like iron 3 sulfide. That 3 refers to the charge on the iron. I want to drop and swap it with sulfide, and I get Fe2S3. If it ends in something other than IDE or acid, in other words, it ends in ATE or ITE, you're going to use the chart of polyatomic ions on the back of the periodic table. However, there are some that are listed back there that don't end in ATE or ITE. Ammonium, hydroxide, cyanide, and peroxide. And those in particular, because they end in IDE, are very confusing to people. Hydroxide is used a lot. You have to remember it's on the back of the periodic table. When you have those, you're going to identify the formulas and the charges. You want to drop and swap the numbers. Keep the parentheses if the subscript outside is greater than 1. Reduce if possible. So ammonium hydroxide, and I put that one on there so we recognize it as being 2 polyatomic ions. Parentheses NH4 with a 1 plus charge, and parentheses OH minus with a -1 charge. When I drop and swap, they both have 1s outside the parentheses, so you can drop them. If it was a number other than 1, you would have to keep it. So lead 2 sulfate, that's a Roman numeral. Pb is 2 plus, SO4 is -2. When you drop and swap, they both have 2s outside the parentheses, so it reduces to 1:1. Okay, so that's writing formulas. Naming it, and again, sorry all the arrows, First thing you want to ask yourself is how many elements are present. And what that means is how many capital letters do you see? If you only see 2 capital letters, then you have to identify what is the first letter. Okay, if it's more than 2 elements, you don't necessarily have to do that as easily. So if it's only 2 elements, if a hydrogen is first, that means it's an acid. And it means it's a hydroic acid because it only has 2 capital letters. That means hydrogen's on the front and whatever the anion is on the front. And so if I had H2S, I see 2 capital letters, it's hydrosulfuric acid. If it's a metal first, what you do is you name the cation and watch out for Roman numerals, and name the anion and they end with IDE. So if I see MgO, 2 capital letters, magnesium oxide, done. No Roman numeral needed for magnesium. Fe2S3, again, 2 capital letters, tells me it's elements that end in IDE. So it's iron sulfide, but Fe is one of those elements that needs a Roman numeral. So to do that, you can do some algebra. The charge on S is 2 minus, and there are 3 of them. And then there's 2 of the Fe that we don't know what charge is. So we have 2x plus negative 2 times 3 has to add up to 0. 2x minus 6 is 0, x is 3. So it's iron 3 sulfide. If it's a non-metal first, you name the first element, you use the root name of the second element, and you end it with IDE, but you use prefixes to indicate the subscripts of each element. So N2O4, I see 2 capital letters. The first one is a non-metal, so nitrogen oxide. But I need prefixes, dinitrogen tetroxide. Okay. If I have more than 2 capital letters, what that means is the H, if it's written first, it means it's an acid. You're going to use the chart of the polyatomic ions on the back of the periodic table. If it is an ATE ion, it becomes ic acid, no hydro. If it's an ITE ion, it's an OUS acid. So HNO2, 3 capital letters. I look on the back, NO2, 1 minus is nitrite. This becomes nitrous acid. HNO3, again, H is first, 3 capital letters. NO3 is on the back, is called nitrate. This becomes nitric acid. If there are more than 2 elements and hydrogen is not first, you want to name the cation and watch out. It could be NH4, and you want to watch for Roman numerals, and then you name the anion. And that's pretty much it. So if I had this, NH4OH, it is not an acid, because H is not written first. It has to be the H first. NH4, I look on the back, is ammonium. OH on the back is hydroxide. So ammonium hydroxide. No Roman numerals there. PbSO4, 3 capital letters. I look on the back, I recognize SO4 is sulfate. So it's lead sulfate, but lead needs a Roman numeral. You're going to insert parentheses with a subscript so that you know that the subscript is 1 outside the parentheses. Sulfate is negative 2 charge. So what you have is the charge for lead, X, plus negative 2 times the number outside the parentheses, which is 1. X is positive 2, so it's lead 2 sulfate. Hopefully this helps you. The rules are a little weird sometimes, but it is pretty methodical. Scientists like to look for patterns, and I've tried to give you as many of the patterns as I possibly can.